In this part of the program, we will be concentrating on introduction and functions of job holding and supporting devices such as 3-jaw self-centering chuck, 4-jaw independent chuck, combination chuck, split jaw chuck, magnetic chuck, and collets. Before mounting a job holding device, its mating surfaces and threads are cleaned with a brush and a cloth piece to remove dust, dirt, and chips. Care should also be taken to clean the spindle nose. After this, the holding device is screwed onto the spindle nose. It is then locked securely to ensure that it does not slip during operation. Three-jaw chuck, self-centering. The three-jaw chuck is a self-centering chuck. All the three jaws move together to grip the workpiece in the center. It is used to hold cylindrical and hexagonal work. The jaws are moved by the scroll, which is a spiral groove cut on the face of a flat disc. As the scroll is turned with the help of a chuck key, all the jaws move together, either towards the center or away from it. Two sets of jaws are available. One for gripping smaller diameter jobs by closing in, and hollow jobs by opening out the jaws. Second set is used for gripping bigger diameter jobs from outside. How are the jaws changed? The jaws are removed from the chuck by backing them out using the chuck key. The slots on the chuck are numbered 1, 2, and 3. Also, each jaw has a corresponding number. Turn the chuck so that slot number 1 is at the top. Turn the chuck key until the top thread of the scroll plate is just short of entering slot number 1. Insert jaw number 1 and set it down against the scroll thread. Turn the chuck key to catch the thread into the grooves of the jaw. Turn the chuck key just enough to meet slot number 2 and no further. Insert and catch jaw number 2. Repeat the same for jaw number 3. If the jaws are correctly fixed, they will meet at the center. If fixed wrongly, they will not meet at the center. Fixing of workpiece. Deburr the workpiece. Check for proper shape and straightness. A round piece should be reasonably round and a hexagonal piece should be reasonably hexagonal. Sufficient portion of the workpiece is gripped inside the holding device and just the required length should be projecting out. In case the projected length is more, it has to be supported either by the dead center fixed in the tailstock or by a steady rest. Four-jaw independent chuck. The four-jaw independent chuck is used to hold most of the work for which a chuck is required. Work of different sizes and shapes can be held by moving each jaw independently of the other. How is the work trued? All the four jaws may be approximately centered by adjustment. The workpiece is then inserted and the opposite jaws tightened just enough to hold the work in place. Bring a cutting tool near the job. Move it in until it just touches the workpiece. Revolve the chuck by hand to locate the high or low spots of the workpiece. Adjust the jaws until the workpiece runs true. If greater accuracy is required, use a dial test indicator. Combination chuck. A combination chuck is usually a four-jaw chuck in which the jaws may be adjusted either together as in three-jaw self-centering chuck or independently as in four-jaw independent chuck. Here, a rectangular piece is being centered and fixed by moving the jaws independently. This method is suitable for mounting a single piece. For batch production work, the first piece is positioned accurately and fixed in the jaws. Subsequent pieces are held together by using a chuck key in the self-centering socket. Split jaw chuck. Split jaw chuck is a six-jaw self-centering chuck with jaws having small steps. The jaws can be opened or closed by moving a knurled ring on it. This chuck is used for holding thin spacers and washers, which are difficult to fix in other work-holding devices. Magnetic chuck. A magnetic chuck holds steel work pieces by means of permanent magnets contained within the body of the chuck. A magnetic pull is controlled by partial or full movement of the key. The chuck is suitable for taking light cuts and for holding parts that are too thin to be held in other chucks. Collets. Precision machines are usually supplied with a set of collets for chucking work pieces with standard diameters or sizes so that the work runs true. The collet has a finished hole to accommodate the workpiece and is provided with slits for squeezing action. The collet and drawbar should be cleaned before fitting. The collet fits into the corresponding taper of spindle nose and is tightened when pulled back. Nicely finished bars within 0.2 to 0.3 mm of the collet diameter should be held in the collet. In case the projected length of the workpiece is more, it should be supported by the dead center. Collets are useful for production of small parts out of a long bar of material passed through the drawbar and held by the collet. After parting of a finished piece, the bar is again pulled out. Work pieces which are oversized should never be forced in the collet. Too much undersized workpieces should also be avoided. Out of round, irregular and pieces full of scale, if used, will destroy the accuracy of collet by deforming it out of shape. This program finishes with chucks and collets. Turning between centers, steady rest and faceplate will be taken up in the next part of the series.